Hey everyone, and welcome back to our video series. We've reached the point where we're now going to be looking at motion. So we've actually hit some of the physics finally and aren't just looking at that algebra. We want to apply that algebraic stuff to actual physics problems here. Now, you've actually dealt with some of these before. You've dealt with d equals rt or dirt problems, distance equals rate times time, and that's really what we're looking at. The difference is that we're looking at distance equals rate times time from the perspective of 8th grade mathematics. We're looking at it from terms of systems of equations and trying to deal with multiple people doing things. They're going to be leaving houses at the same time or different times, all this kind of stuff. So it's a bunch of word problems. It's pretty fun. They're cool little puzzles. So one thing you're going to need to start figuring out is how to look for the right terms. So my first question here is, how far will you go if you travel 60 miles an hour for 5 hours? Well, how far will you go? That's asking you about a distance. So I'm solving for distance in this case. 60 miles per hour is a rate, and 5 hours is a time. I can tell 60 miles per hour and 5 hours are rates and times immediately because of the units. Okay. You're going to want to start looking at the units on things and getting a sense for what the units mean. The kids who can sort out that a miles per hour is a rate and that 6 miles is a distance, those kids who can sort that out are going to do a lot better than the kid who's looking at that 60 going, I don't know what that is. I don't know what part of this that is. Second one here, we got, I walked for 6 miles in 3 hours. What's my speed? Speed's another word for rate. So I'm going to plug in the 6 miles in for the distance. I'm going to plug in the 3 for the time. And I'm solving for the rate. And how long will you walk? It will take you to walk 12 miles if you walk 3 miles an hour. Well, how long is a way of talking about time in this case. And we got 12 miles and 3 miles per hour. I can tell that it's time really easily because that's the missing one. 12 miles is a distance. 3 miles per hour is a rate. So I plug it in, and there you go. All those are very easy to solve problems. They're all one-step equations. Nothing too serious there. So let's take a look at something that's a little bit more 8th grade. And today we're going to focus on opposite directions and total distance problems, okay? Now, the way we tackle word problems in physics often is to start by making a sketch and making a table. Now, personally, I make just the picture. I go from picture to equations when I'm doing things. Some people skip the picture. The picture's not helpful for them. I'm more of a visual learner, so I like to do a picture. And it's really just a rough sketch. Don't think you got to like draw the Mona Lisa here to solve a math problem, okay? Some people prefer the table, and they just go to the table and that's it. It's really up to you how you want to try to get your head around the situation, okay? The key skill, to be honest, is to just do a bunch of these and get familiar with the units. Get familiar with the way the questions are asked, and you'll do very well with them. Okay? So let's take a look here at a situation. We got 2 cars. They're leaving the town at the same time, going in opposite directions. One of them's going 60 miles an hour. The other's going 30 miles an hour. In how many hours will they be 150 miles apart? So we're going to start off. We got 2 cars, and they're going to go in opposite directions. There they go. They drove in opposite directions. One of them cars went 30 miles an hour. The other car went 60. And I want to know how many hours. I want to solve for time. How much time will it take for them to be 150 miles apart? Well, let's go ahead and throw this into a table. This is a good one for a table. We know that the slow car does some distance and the fast car does some distance, okay? The rates, well, the slow car was going at 30 and the fast car is going 60, okay? I want to figure out how much time it took. And we know that they're traveling the same amount of time in the problem. So time is just going to be t. Now check it. yesterday with elimination method, I learned I could literally add equations together. And I know the total distance is 150. That total distance would have to be the distance of the slow car plus the distance of the fast car. So if I add these two equations together, I can set distance to be 150 because distance plus distance is 150. I know that. I know that from the problem. I don't really need to know how much of that the slow car did or how much of that the fast car did in this particular problem. There are situations where we can look at that. But for this one, I don't need to worry about that. I'm trying to solve for time. So don't try to answer questions that you're not being asked is the first rule of physics problems. Okay? Look at what you're being asked to solve and figure out what you got to do to solve that problem. Okay? Well, 30t plus 60t equals 150 would be the result of adding these two equations together because the distance of the slow and fast equals the 150. 30t plus 60t equals 90t. All right, divide by the 90, and I got the time as 1 2/3 of an hour. Cool. Or an hour and 40 minutes is another way to phrase that. And that's it. You're done right there. That was it. That was all. 150 divided by 90. All right, we got two cars. They're leaving Rockland. One car travels north, 65 miles an hour. The other goes south at 55 miles an hour. We want to know how long it takes them to get 420 miles apart. There's my picture of Rockland. It's the most masterful piece of art that has ever been seen. It's a dot. It is a dot. All right, one car is going north at 65 miles an hour. The other one's going south at 55 miles an hour. Notice that they're actually going east and west in my picture. Oof, my pictures are sometimes not the best. All right, I want to know when all of that is 420 miles apart. All right, cool. Well, I know that the slow car went some distance, the fast car went some distance. I learned from the last problem that I can just add those distances together. In this case, it's going to be 420 miles. Sweet. I don't have to do much there. One car was going 55, the other was going 65. Now, they both traveled for the same amount of time, so time is just t. And this is literally going to be a lot like the last problem. I add those two together, I get 420 equals 55t plus 65t. 55 plus 65 is 120. 420 divided by 120 is 3.5 hours. You have to have your units. If you don't have units on a physics problem, you are way wrong. Okay? Believe it or not, I care about the units very, very much. You will lose points. There's actually been students I've had who've done very well with physics problems on tests, and then they leave off the units. And then their A-level work becomes B-level work because they didn't include units on everything. It has happened. It literally takes a 12-question test and 1 point off for units on each of those questions, which is standard. That's very standard with me, and it has resulted in students who got everything right getting a B+ because they didn't include their units. You have to be very conscious about that. It's really about the details. All right, here we got a marathon runner. She's doing a 32-mile long course. For the first part of the course, she's averaging 10 miles an hour, and for the second part of it, she's averaging 6 miles an hour. I want to know how far she went in each section of the race if she spent the same amount of time in each section. She spent the same amount of time in each section. Time is the same. We got a 10-mile-an-hour section. We got a 6-mile-an-hour section. And grand total, she ran 32 miles. So distance slow plus distance fast is 32. Here's my photo of it. So she went some distance for 10 miles an hour. She went some other distance at 6 miles an hour. Grand total, she went 32 miles. So the first part of the race is 10. Second part of the race is 6. We know that she spent the same amount of time in both. So time is just t. And if we added it together, we would get 32 that she went. So 10t plus 6t gives me 16t, which means she did 2 hours in each section. Now I go back to my equations. 10 times 2 gives me 20 miles for that first part. 6 times 2 gives me 12 miles for that second part. That's my answer. How far did she go in each section? Right there. 10 miles in the first part, or 20 miles in the first part, 12 miles in the second. That's really it. That's systems of equations applied to motion problems, which was really the point of going back through those. We're going to see systems of equations for a bit and lots of different problems. These problems aren't going away, so you're going to honestly want to practice them. You just want to do a bunch of these until they start making sense. That is my honest advice to you all. Is if you're struggling with these, do more of them until you get used to the language, until you get used to the units, until you get to the point where this is really just second nature to do. Okay? And then you'll do really great with them. They're really not hard when you've done enough of them that they're easy. I think that's when you know you've done enough of a math problem, when it's super easy and trivial. If you are struggling with a math problem type, you haven't done enough of them. You just got to practice. It's a lot like working out anything else. Okay? It's just like working out. If you're struggling with it and it's hard, you probably need to keep going until that becomes easy and it becomes second nature. That's my honest advice. So I'll see you in class tomorrow. I hope this all made sense, and have a great night. Bye.